Hi, welcome to lesson number 6 on the tutorial series on practical electronics designs. Today we'll be building another circuit, and this circuit is referred to as the LED flasher circuit. So what this means in essence is that we are going to have two LEDs, and the first one will flash, it goes off, the second one flashes, goes off, flash, flash, flash. So whenever this one is on, this one will be off. Whenever this one is on, this one will go off, and they keep alternating continuously as long as the circuit is powered on. But before we go into building the circuit, it's good we understand the working principle of the circuit. This is the circuit diagram we're going to be using. Here you can see that there are several components there. We have series of resistors arranged in parallel. We have two identical capacitors of 100 microfarad each. We have two transistors. Remember, in my lesson number 3 I talked about transistors as electronic semiconductor device that are used as switches. Primarily they are used as switches, so they switch the states, one on state, off state, on state, off state. So they keep switching the states for us. This a transistor, an NPN transistor. I'm going to explain this as we proceed. Then the output of one is used to power this LED through this resistor, and then the output of the second output is to power the LED through this resistor. Now, how does a transistor work? It's very important to understand how a transistor works, because without understanding how a transistor works, you cannot understand how this circuit works. A transistor, the way I'm going to explain a transistor is I'm going to use a tap. This is just a symbol of a transistor here. This is an NPN transistor. I told you in our lecture number 3 that we have two major kinds of transistors. We have the NPN and the BJT. Okay, should I say types of bipolar junction transistors, because we have other kinds of transistors, but for bipolar junction transistors, BJTs, we have two major types: the PNP configuration and the NPN configuration. So in the NPN configuration, okay, that's what I'm going to explain now, but just know that they are almost the same. The only difference is that whatever condition turns on the NPN, that same condition turns off the PNP, and whatever condition turns off the NPN, that same condition turns on the PNP. So they work in opposite ways. But once you understand this, understanding the PNP will not be much of a problem. If you want to understand more about the theory behind the working of transistor is a very is a very broad and wide. In fact, understanding is very wide. It has a very wide scope. So many configurations and so many calculations. But I said this our tutorial is strictly for practical designs, and so I'll reduce the calculation and the theory as much as possible. The transistor has 3 terminals. This is the base, this is the collector, and this is the emitter. You can see I used B, C, and E to represent that. Similar to this tap, you can see this tap too has 3 should I say, we have the control knob, we have the inlet, and we have the outlet. So we can use this analogy to explain how a transistor works. The way our tap works is very simple. Whenever you control, based on the control you give on the knob, water will either flow through the tap or water will not flow. So once you open the tap, water flows. Once you close the tap, water doesn't flow. That's how a tap works. So bring it out to a transistor. Once you control, based on the control you give to the base, it will determine if current will flow from the collector to the emitter. So based on the control you give at the base will determine if current will flow from this collector point to the emitter point. And this is the easiest way to bias a transistor, to connect an NPN transistor. We have a resistor connected to the base. We have another resistor called RC connected to the collector. They are just doing the function of current limiting, opposing the flow of current so as not to damage this guy. And also for the gain, I may not cover the gain of a transistor in this design, but one thing I must say is that the gain of any transistor can be seen in the data sheet of a transistor. Transistors can also be used as current amplifiers. So when you talk of amplifying, it has to be multiplied by a factor. That factor is the gain of the transistor. So now, if this is the configuration of a transistor, what control do we give to the base that will determine if this transistor is on, allowing current to flow through, or if this transistor is off, hindering current from flowing through? The condition is very simple. You must apply a voltage between the base and the emitter. So that voltage is called VBE. I've said before that for current to flow, there must be a potential difference. There must be a reference point. So this is the voltage at the base reference to the emitter. The emitter most times in this configuration is usually connected to the ground. So this is 0 volts. So reference to the ground. So the voltage you apply here will determine the current that will flow, IB. Once you apply a voltage here higher than greater than 0.7, the transistor is going to close. It's the switch. I've said transistor works as a switch, so it's going to close and it's going to allow current to flow from the collector to the emitter. It's going to close and current will flow. So the condition that controls the transistor is that you must apply a base emitter voltage greater than 0.7. At that point, the transistor is said to be at the saturation mode or saturation state. Simply means that the transistor is on. So once you apply a voltage to an NPN transistor, at this point the base emitter voltage greater than 0.7, the transistor comes on and it acts as a closed switch. So it allows current to flow through. Of course, when a switch is closed, the voltage there is 0 because there will be no voltage drop across that place. That's maximum current because it's just a closed circuit. And when the voltage, the base emitter voltage is less than 0.7, the transistor is off. It's in its cutoff state or cutoff mode, cutoff region, as the case may be. So once it's less than 0.7 volts, no current will flow through because it's going to serve as an open switch. And when you off your switch, current doesn't flow through this circuit. It doesn't current only flows through a closed loop. So once you meet the control condition, just like the tap, once it is open, water flows. So once you meet the control condition of having a voltage greater than 0.7 across the base and the emitter, you allow current IB to flow through to turn on this transistor. And then when this is less than 0.7, it turns it off. So I think that is just how a transistor works. Now, a capacitor, I think it's important I also let you understand how a capacitor stores charges, because I'll be dealing with capacitors too in our circuits. Capacitor, once you connect a direct current voltage source to a capacitor, the positive terminal of the battery or the source produces positive charges on one plate of the capacitors, and the other terminal, the other plate, you get negative charges. So this is something you just need to understand. It may be useful for you. It will be useful for you in our future lessons. Okay, now the multivibrator circuit using a BJT. A BJT is a bipolar junction transistor, and that's what we have here, this normal kind of NPN transistor. It works in this circuit as a switch, so it helps us to change the states, two states, and we're going to be using it in the Astable mode. I'm going to explain what that means, but just look at this circuit very well. Once this LED is on, this LED will be off. When this LED is on, this one will be off. That's just the whole idea of this circuit. Okay, we have types of multivibrator. We have the Astable multivibrator, that's the free run multivibrator. We have the monostable and the bistable. In this circuit, we'll be dealing with the Astable multivibrator, so we don't have any business with these two. We'll deal with these two in our future lessons. Okay, now what is an Astable or the Astable multivibrator? A multivibrator that generates square waveform without any external triggering pulse is known as an Astable or free running multivibrator. That means if we design a multivibrator circuit that keeps generating square waves continuously without any triggering, once you just connect the circuit, it keeps generating the pulses. That means the LED keeps flashing on off without any triggering, without any external triggering or sending any pulse or any control whatever to the circuit. just by connecting power to it, it begins to oscillate, it begins to generate pulses. That is a stable multivibrator. And this is the working of the circuit. Now I'd like us to pay attention at this point, because it's good to always understand how the circuit works. We have two transistors that will never be in the same state. A stable mode, they can never be in the same state. So how do they work? Current will, whenever you power these circuits, because of circuit mismatch, one transistor will come on while the other one will go off. You cannot predict which will come on and which will go off. Anytime you power it, anyone will come on first and the other one will go off. You can't really determine and say, oh, this is the one that will start. So once it starts, then it begins to alternate. So that is just one of the ways this BJT kind of a stable multivibrator works. Once you just connect your power, one transistor will be forced to come on while the other one will be forced to go off. And let's assume this one goes on first. So if this one goes on first, that means it closes like a switch. This one will be open like an open switch. This one will be closed, a closed switch. So we're going to have something like this. So current is going to, once this one closes first, current is this particular switch closes, this one opens. And so you notice that this end of the capacitor and this end of the resistor are already connected to 0 volts. That's the ground, connected to the negative terminal of our battery, of our 9-volt battery. So at this point, since it's short circuit, since it's closed, the voltage across this point will be 0 volts, because it's just going to serve as a straight wire. So there's no voltage drop across, it's just 0 volts. And of course, you know that the voltage here is the same voltage that will be at this point. Look at this, at this point, 0 volts. So once this one is closed, we are going to see 0 volts across this point. That's going to be the same voltage that will be across this point. And remember, when we have a voltage less than 0.7, the transistor is going to be off. And that's why this one goes off, because this one comes on. Since one closes, this one has to go off, because the voltage that is going to see at this point is going to be less than 0.7. It's going to be 0, because this one has closed. And so once this one goes off, what then happens? Because this particular transistor is off and is open circuit, current doesn't flow through open circuit. In fact, current prefers to flow through a path of least resistance. So because of this open circuit, the resistance value is at infinity, is infinite resistance. No current is going to flow through this resistor, because it knows there is no way here it can't flow through to ground, and current flows only in a closed loop. So current will not flow through this resistor to this point. Current also will not flow through this point too. So this is going to be the new direction of current. Current is going to flow through this base resistor. This RC1 is the collector resistor of the transistor. This is the base resistor of transistor 2, because this is the resistor that's connected to transistor 2. Then this is the base resistor of transistor 1, and this is the collector resistor of transistor 2, that's RC2. So current begins to flow through this base resistor of transistor 2 and begins to charge this capacitor. So as this capacitor begins to charge, it charges to a point that the voltage across it is greater than 0.7. So it begins to charge. As it begins to charge, the voltage starts climbing up. So the voltage before now, when this one was turned off, was less than 0.7. But as it begins to charge, it sees a voltage here greater than 0.7, because the capacitor will want to charge to the value of the supply voltage, 9 volts. So it will want to charge to 9 volts, but once it gets to a point that is greater than 0.7, immediately it turns this one off. Why will it turn this on? Because once 0.7 volts, greater than 0.7 volts, is applied to the base here, this one has no choice than to come on. And once it comes on, it serves as a wire, and the voltage drop across a wire is 0. And that same voltage from here to here is what is also seen from here to here. So we have 0 volts here, and when we have 0 volts across this base, the base of transistor number 1, that voltage is less than 0.7, 0 volt is less than 0.7, transistor 1 is forced to go off. So you see that there will be no point when both of them will be turned on. They will keep alternating. If you didn't really get the picture, you can let me know in the comment section. You can also go through the video over and over to understand what I'm trying to explain. So whenever this one is turned off, this one will be turned on, and when it's on, the output, there will be a current flowing through the output through this resistor, and to turn on this LED. So when this one goes off and the output here is on, current will flow through this resistor and turn on this LED. So that's how this circuit works. That's the working principle. So now it's time for us to build. So we're going to get our breadboard and other things to build this circuit.